Albert Einstein wanted to explain relativity without relying on a heavy mathematical apparatus. He wrote for readers with a standard education, aiming to reveal the philosophical core of how we experience reality. For centuries, the physics of Galileo and Isaac Newton ruled our understanding of the universe. In their view, space is a fixed, flat stage, and time ticks at a single absolute rate for everyone, everywhere. To locate an event in this classical universe, you need a rigid body of reference. If you want to meet someone in Times Square, you rely on the Earth as an immovable foundation, using the grid of the city to lock down exact coordinates in space. But light breaks this intuitive system. Measurements reveal that light moves through a vacuum at exactly 300,000 kilometers per second. That speed never changes, regardless of whether the source emitting that light is sitting completely still or rocketing forward. If a person running and a person standing still measure the exact same passing beam of light, they both record the exact same speed. The math forces a difficult conclusion. If light refuses to adapt to the observer, our rigid rules for space and time must be wrong. To solve this, imagine a long railway carriage traveling uniformly along an embankment. Lightning strikes the tracks at exactly 2 points, far ahead and far behind. To an observer standing perfectly still on the embankment, exactly halfway between the strikes, the flashes reach his eyes at the exact same moment. They are simultaneous. But consider a second observer riding precisely in the middle of that moving train. Because the train is traveling forward, this observer is physically moving toward the light from the front strike and away from the light in the rear. The flash from the front arrives first. To the person on the train, the strikes did not happen at the same time. Physics required a new mathematical framework. Hendrik Lorentz developed equations showing that distances actually contract and time literally slows down depending on how fast you are moving. Space and time could no longer be treated independently. Building on this, Hermann Minkowski proposed that the universe is a four-dimensional continuum. Time is simply the fourth coordinate woven directly into the 3 dimensions of space. Time is not a master clock ticking uniformly across the cosmos. It is a highly personal dimension, dictated entirely by an individual observer's specific state of uniform motion. Unifying space and time proved to be an incredibly useful tool. Einstein noted the theory had great heuristic value. It forced other independent laws of physics to merge. When applying this to the equations for momentum and electromagnetism, a strange dynamic emerged. If a moving body absorbs a massive amount of energy, its inertial mass literally increases. The object becomes physically harder to accelerate. This relationship resolves into the equation E equals mc squared. Energy equals mass times the speed of light squared. The conservation of energy and the conservation of mass are the same law. Matter and energy are not separate categories of reality. They are 2 different expressions of the exact same physical property. Yet a critical flaw remained. Special relativity only works for objects in uniform, unchanging motion. It completely ignores what happens when an object accelerates, hits the brakes, or rotates. To address this, Einstein proposed another thought experiment. Imagine a windowless chest suspended in a deep, empty void of space, far from any stars. Suddenly, a hook on the roof catches, and the chest is pulled upward with violent, constant acceleration. Inside, an observer is pressed against the floor. If they release a rock from their hand, it drops toward their feet. With no windows to see the stars, the observer naturally assumes the chest is resting stationary in a uniform gravitational field. But an observer floating completely still outside the chest sees something else entirely. There is no gravity. The rock simply remains at its current speed, while the floor of the chest accelerates upward to intercept it. The force you feel holding you to the earth is indistinguishable from the force pushing you back in an accelerating vehicle. Inertial mass and gravitational mass are functionally identical. If gravity mimics acceleration, and acceleration affects how we measure light, how does this non-uniform motion warp the physical shape of space and time? Picture a flat disk spinning rapidly. You place 2 identical clocks, one in the middle, one on the edge. To an outside observer, the edge travels at high velocity. Because moving objects contract, a measuring rod at the edge shrinks, and its clock ticks slower. Because rigid measurements fail in an accelerating field, flat Euclidean geometry, the math of straight lines and perfect squares, breaks down. To map this reality, physicists must use Gaussian coordinates, a flexible mathematical grid that can stretch and deform. This flexible grid applies to the actual universe. The presence of massive objects physically stretches and curves the four-dimensional grid of spacetime. Gravity is not an invisible tether pulling planets together across an empty void. It is the literal geometric curvature of the spacetime fabric. Objects simply follow the straightest possible path through a warped dimension. Theory requires proof. If the sun's massive weight curves space, light from distant stars should follow that curve. During a total solar eclipse, when the sun's glare is blocked, stars near its edge should appear visibly displaced from their normal positions. In 1919, an expedition led by astronomer Sir Arthur Eddington photographed a solar eclipse, proving that the starlight did exactly what the geometry predicted. The mathematics of curved space also resolved a mystery closer to home. For decades, astronomers had noticed anomalies in the orbit of Mercury. General relativity perfectly predicted its shifting path around the sun's deep gravitational well. By proving mass dictates the shape of space, Einstein revealed a new cosmos. The universe is finite, yet unbounded, capable of expanding continuously. You are not a passive passenger sitting on a flat, universal stage. Your very mass, presence, and motion actively weave the geometry of reality itself.